Section 2.3, slope-intercept form. We'll start our discussion about graphing lines. First couple things we need to talk about are what we call family of functions, just a group of functions with common characteristics. So everything we're talking about here is going to be lines. So all lines are very similar. They have parts to their structure that if we learn the particular parts, then without even having to graph it, we should know kind of what it looks like. And even looking at graphs, we should then be able to go in the reverse and know what the algebraic representation of the line looks like, just by knowing the similar characteristics that are shared by all lines. We have what we call parent function, and that is the simplest function with these characteristics. So for our lines, the simplest line we can come up with is y equals x. Now you'll often see it as f of x equals x, and that was the function notation. And all lines pass the vertical line test. So every line we write can be y equals whatever the equation is, or f of x equals whatever the equation is. So the linear equation is an equation that models a linear function. The graph will be a line. Some key things to talk about that you've heard before. Intercepts. Okay, intercept means to pass through. So they are the coordinates in which the graph crosses one of our axes, either the x-axis or the y-axis. So an x-intercept, you can see down here, there's an x-intercept right there on this graph. That's where our line crosses the x-axis. Here we have a different function. This is a parabola, but we still have where we cross the x-axis, so we still have x-intercepts. Where we cross the y-axis, those are obviously then called y-intercepts. Okay. As long as the line is non-vertical, so it's not straight up and down, it will always have a y-intercept. And as long as it is non-horizontal, it will always have an x-intercept. And if it's non-vertical and non-horizontal, it will always have both a y-intercept and an x-intercept. That's kind of what this here is talking about. So for any and all x-intercepts, the y value is always 0. And for any and all y-intercepts, the x value is always 0. So if I had a line here, let's say that we're going to point there, and let's say we got a point right there. If we connect those with that red line, okay, so this one here would be my y-intercept. And if we look at its ordered pair, remember our ordered pair is at x value first. So how do I go from 0, 0 to get there? Well, I don't move left or right, so the x value is 0. And I move up 4, so my y value is 4. And that's what this is saying. For all y-intercepts, x value is always 0. And that's what we're seeing here. Your x-intercept, the x value, now from 0, 0, we got to go over 6. But then we do not go up or down to get to that point from 0, 0. So my y value is 0. So y value, x-intercept, the y value is always 0. And that's what we're seeing right there. Now, however you want to move those points around, kind of show you or demonstrate this here with GeoGebra real quick for you. So I just put in any line here that I want and ask it for that point C and that point D, okay? And if you look at these two right here, so C is your y-intercept, okay? No matter what my line looks like, if we look at that C right there highlighted, no matter what my line looks like, you can see that showing you right there. No matter what my line is, that x value is always 0. Okay. Now if I look at this D value right there, no matter what my line is, that D value for the Y, that's always going to be 0, no matter what. Okay? So if we're looking at D and C here, those 2 points, the X is always 0 for the Y-intercept, and the Y is always 0 for the X-intercept, no matter what my line looks like. So each linear equation can be written in what is called slope-intercept form, and that's the key thing that we're going to talk about here in this section. And basically what it means is that they're going to give you the slope, or you can gain the slope from this form, and you can determine what the intercept is. Now it's a specific intercept. It's actually going to be the Y-intercept. Okay. So when we do this, okay, the letters that I've made black here, the Y and the X, they're going to stay Y and X. They're never going to change to anything else. But the M is going to be a number. It's going to be a real number, and that represents your slope. Okay, so that's the slope portion of the name here. This number right here, and it says plus B in the formula, but it might be minus. Okay, that number with the sign is my Y-intercept. That's where we cross the Y-axis. Okay, your Y, okay, this amount is your dependent variable. Okay, and it depends on what this value right here is. Okay, so this Y value is what we're going to call our range or our output, and this value here is our input or our domain. Something that we should have known from a previous course is slope. Slope is rise over run. Okay, and we determine rise on our graph by subtracting 2 Y values, and then we do the run, which is the horizontal distance, and we find that by subtracting 2 X values. Now the way I've gotten this written, I just didn't copy over from the program very well. Those are subscripts. And it doesn't really matter. You can even write it as Y1 minus Y2 over X1 minus X2. The only thing that you got to pay attention to is you cannot say like Y1 minus Y2 over X2 minus X1. That'll mess your signs up. Whatever the subscript of this one is, this first Y has to be the same as the subscript for the second X. Or sorry, for the first X. They can't be like this where I've got 1 and then 2. They got to be 1 and 1 and then 2 and 2. Or 2 and 2 and 1 and 1. So in this particular problem, it says what are the slope and y-intercept of the graph of y equals 5x minus 2. So all we have to do is put our slope-intercept form right underneath it, and we just compare. So that number and that number go together or match up. That number and that number match up. So my slope is 5. My y-intercept, now you got to use the sign, so it's -2, which would be the point. Remember, for the y-intercept, the x value is always 0. The y value then is the intercept. This one here, a little bit different because the x term is not coming first, so what we can do is rewrite that as -2/3. I use my commutative property. So when I use the commutative property, remember I got to take the sign too. So I'm going to move the -2/3 x out front, and then I'll move the -3 to the back. So now you can see if we align the y equals mx plus b, you're going to see your slope is at -2/3. And then your b, or your y-intercept, is equal to -3, and that will give you the ordered pair 0, -3. Example 3 here. Now you're going to write the equation. So they tell you the slope. So they say slope is -4/5, so that's m. And the y-intercept is 7, so that's b. So now all we have to do is plug that stuff in to this general form. So m was -4/5, and b is a +7, so we'll say +7. And there's the equation that has a slope of -4/5 and a y-intercept of 7. right, so the next thing they do, those should have been like review from Algebra 1, use them in geometry. We get to example 4 here, and it's a little bit more involved. Whenever they ask me to write an equation, somehow they're going to tell me the slope and the y-intercept. Now, they may not be explicit with that. They might not tell you right off the bat, hey, this is your slope. But if they give you 2 points, we call that point x1, y1, and x2, y2, we should be able to generate our slope by taking our rise over run formula. So we go y2, which is 10, minus y1, which is 6, over x2, which is 0, minus x1, which is 4. So it's going to give me 4 over -4, which ends up being -1. So they didn't blatantly or explicitly tell me what the slope was like they did in example 3, but they gave me enough information to determine what it is. I know it's now -1. So m is -1 when I write y equals mx plus b. Now, one thing you got to pay attention to is I got to figure out what b is. I need to find out what y-intercept is. And this is a little bit easier in this one, but I'll show you a couple different techniques that you can use. That right there is your y-intercept. The x value is 0. If my x value is 0, think about this. If I were to plot that, my x value is 0, I would go up to 10 on my y-axis. That's my y-intercept. So b is 10. Okay. Every y-intercept, if we want to think about it this way, is going to be 0, comma, whatever the b term is. So whenever you see a 0, comma, whatever, then that whatever, in this case it's 10, is going to be your y-intercept. So b is 10. So now if I want to rewrite my equation, I go y equals mx plus b, but m was -1, and b is +10. Okay. If you don't like that, if you don't realize that, and some people aren't going to realize that right away, that that's a y-intercept, you can do it this way. You know your slope. You know your slope was -1. So I'm just going to plug that in. But I don't know anything else. But what I do know is that either one of these points is on my line. And this rule is actually a algebraic rule or equation that will generate these points. So what this is saying is that if I plug in, that's an x value and that's a y value. If I plug in y to be 6, x to be 4, I should be able to determine what b is. Because I don't know b, I'm looking for that, so it would be unknown. So now I can rewrite this as 6 equals -4 plus b when I multiply those together. Add 4 to both sides, gives me b to be 10. Well, now we come back up to here. Now that I know what b is, I can plug that in as 10. Now you say, well, how do you know to use 4, 6? I didn't. I could have gone y equals mx plus b. Okay, let's use this second one. So y is 10. M is -1. The x that they're telling me here in this blue point is 0. And then plus b. Well, I get that. So 10 is equal to b again. And come back up. Should have wrote it as y equals -1x plus b there. If I come back up to that, just like I did right here, plug b back in as 10, and I've got my equation. There's actually another way, which we'll get to in the next couple sections on how to do that. Example 5 says what equation in slope-intercept form represents a line that passes through the points 2, 1, and 5, -8. So it's the same idea. So I'm going to say slope, x1, y1. And people always say, well, how do you know to name that one x1, y1, and this one x2, y2? I don't care. You can flip them. I just go, first one I see, I usually write x1, y1, second one x2, y2. So remember, slope is y2 minus y1 over x2 minus x1. So in this case, y2 is -8 minus y1, which is 1, over 5, which is x2 minus 2. So we get -9 over 3. That reduces to -3. So now, if I want to write my equation, I'm going to go y equals mx plus b. Okay, I don't know what b is yet, and this one is, it's not like the previous one where I had a 0 for the x and I knew that 10 was automatically going to be my b. Now I don't have that, so now I do have to use one of these techniques here. So I'm going to just choose this first point. So y is 1. M. Actually, let's do it this real quick. Let's plug in what I know to be my slope. And you don't necessarily need this step, but I think it's helpful. So I have that, knowing my slope. Now gaining one of these points, I'm going to plug in y to be 1. I have my -3 times 2 plus then b. That's 1 equals -6 plus b. I'll add 6 to both sides. So 7 is equal to b. So I'll come back up here, plug that in. I should get the equation y equals -3x plus 7. Okay. Now, if you have time, what I always like to do is check that. And the way I can check to make sure that is right is do the exact same thing, but use the second point instead. So say y equals, it was -3x plus b again. Choose the 5, -8. So y is -8. X is 5. So we get -8 equals -15 plus b. Add 15 to both sides, so that gives me 7 here on the left. So add 15 there, add 15 there, and it gives me b. And come back up to that line there and plug in b. So y equals -3x plus 7. That and that are identical. And that should validate, that should prove that it doesn't matter when you do this which x1 and y1 you use once you have your slope. Do one more here for you. Slope y2, so it's going to be y2 minus y1. Just be careful, it's always minus. Okay, that's part of the formula, so that's the one that's in the formula, and it's a -2. And then x2, which is 1, minus 3. So it's going to be -3. Remember, a minus and negative turns into a positive, so it's actually -3 plus 2, and then 1 minus 3. So I'll have -1 over -2, and that will turn into 1/2. So that's my slope. So now I write in my equation, it's going to be y equals mx plus b. So we got y equals -1/2 x plus b. So it doesn't matter, but let's choose this first point. Y is -2. -1/2 x is 3, and then plus b. Well, that's -2 equals, this will give me -3/2. And multiply fractions straight across top, straight across bottom. Now I'll add 3/2 to both sides, so I get -2 plus 3/2 equals b. Now I like to write this so that it's a fraction, so I need a common denominator, which will be a 2. So you multiply the top by 2, so it'll be -4/2 plus 3/2 equals b. And that ends up being -1/2 is b. So in this case, we actually have y equals -1/2 x minus 1/2. Another thing that you can do, instead of, if you want to check that, instead of writing the other equation or doing that whole process again with this point here, is what you can do once you have this equation should generate these 2 points. So I should be able to say, okay, well, if this is my equation, let's take and see what I get. Do I get -3 when I plug in x to be 1 here? So I get -1/2 x is 1 minus 1/2. So I get y equals -1. Made a mistake here somewhere. So slope was -3 plus 2. That's -1. 1 minus 3 is -2, so 1/2. So the y was -2. So -3/2. Add 3/2. Negative 4 halves, so that's negative 1 half. I apologize here, I found my error. Notice right here when I did slope, it gave me negative 1 over negative 2, which I wrote as 1 half. But when I plugged it in over here, I plugged it in for some reason as negative 1 half. So that's the benefit of checking if you've got the tools to check yourself. Because if I didn't, I would have circled this and said I'm done. That's my equation, and it doesn't model this. Okay, so simple mistake. So that should then allow me to put a y as negative 2. I have my 1 half, so x is then 3 plus b. So now I get negative 2 equals 3 halves plus b. So negative 2 is negative 4 halves. I'll subtract 3 halves from both sides. That will give me b. So we get negative 7 halves equals b. So now, plug that in up here. So negative 7 halves is my b, where that was a positive 1 half x. And now I can check this point. So I'm going to take that point and plug it in. So y is negative 3. I get 1 half. X is 1 minus 7 halves. So basically when I do it this way, and I'll show you an alternative way as well, I'm just going to see if is this true. Does negative 3 equal, so 1 half minus 7 halves, well that's negative 6 halves, which does end up being negative 3. So it proves that when I plug that point in, I get a true statement. So that must be my equation. Another way you can do it is to say, okay, if I'm going to start with y equals 1 half x minus 7 halves, if I plug x in to be 1, what does that allow y to be? Well, you get 1 half minus 7 halves. It says y then is negative 3, and that's exactly what we're looking at right there. Y is negative 3 when I chose x to be 1. I always think it's beneficial, guys. I've been doing this a lot longer than you have, and you can see just a quick transpose of a sign can obviously impact the entire problem. So if you can check it, check it. Those of you that are struggling maybe with adding and subtracting fractions, stuff like that, Desmos is a great tool. If I go to Desmos real quick, and I don't want you to live on this because there are applications of when we need to be able to do this by hand or from memory. If I go negative 2 and I wanted to subtract 3 halves from it, so type in 3 halves. Now all you have to do, you got to make sure you put the fraction that you're subtracting in parentheses. But then you see this little icon here, it says convert to a fraction. Automatically does that for you. You can see our common denominators, all that kind of stuff. So that's convenient if you want to use that. All right, so we got some special cases. Okay, it says, what is the slope of a horizontal line? Well, if I got a horizontal line, let's kind of think about, let's just say that I got a horizontal line that's passing through right here, through this y value of 3. So on this horizontal line, let's say I've got a point right there called 2, 3. And let's say we got a point out here, 3, 4, 5, 6, 7, 7, 3. And to be honest, it doesn't even matter if it was 2, 3, 7, 3, if it's 11, 3, negative 15, 3. It doesn't matter what 2 points you use. Okay. If I look at the slope here, slope, remember, is y2 minus y1 over x2 minus x1. Look at your y's. In this case, because it's horizontal, your y's are the same number. So think about it. No matter what it was, okay, if I had a horizontal line going through 4, it'd be 4 minus 4 up top. If it was through negative 10, it'd be negative 10 minus negative 10. But regardless of however it is, if it's horizontal, this number on top is going to be 0. And because it's horizontal, this number on the bottom, I don't care what this number on the bottom is. In our case, it's going to be 7 minus 2, which is 5, but it doesn't matter. If it was 11, 3 instead of 7, 3, it would be a 9 on the bottom. But 0 divided by anything is 0. So I don't really care what this number is on the bottom. As long as the numerator is 0, my quotient's going to be 0. So what's the slope of a horizontal line? The slope of a horizontal line is always 0. And it's the number 0. Okay? Here it says write an equation of a line that is horizontal and has a y-intercept of 3. Okay? Well, think about this. If I go y equals mx plus b, we just said the y-intercept was 3 and the slope was 0. So I have something like that. But now we know if I take 0 times anything is just 0. So I really got 0 plus 3, which we usually just write as y equals 3. If you have a horizontal line, any horizontal line, no matter what, let's see if we can do it this way. I'll show you this in GeoGebra. Let's see, we want a line through that point, and we'll go perpendicular, or parallel to that. You see right here, it automatically tells me the equation of this horizontal line. It's just y equals 4. Any horizontal line is going to start with y equals, and then it's the y value that passes through. So as I move this, see now it goes to the y value of 3, y value of 2, y value of 1. Any horizontal line is just the y value, y equals the y value that it passes through. And think about why this is the case. If I'm just going to come up here to this one here, and I'm going to put a bunch of points on here. And these are all random. But what does it tell me my y value for all those points? What is my y value always going to be on those? You see that's always 5, and that's why this is the equation y equals 5. If I were to move my line, let's move it down. Let's go up. Now this one fell off the line for some reason. But if I'm now at y equals 6, look at all the y values for all those points. And they're for all of them. Okay, it doesn't matter. Those y values do not change. So when it's horizontal, it's y equals the y value that you pass through. Let's do a vertical line. Slope of a vertical line. Well, if I go to slope of a vertical line, you're looking at something like this. Now I choose that point. So now they're going to have the same x value. So maybe I've got like a 4 comma negative 3 here. And if it's vertical, then that's going to be an x value of 4. Let's say it's 4 comma 7. Well, find the slope. It's y2 minus y1 over x2 minus x1. Now if I do the y's, I'll get 7 minus negative 3. And now if I do the x's, it's 4 minus 4. So here you see I get 10 over 0. And that is something we're not allowed to do. You cannot divide by 0. So slope, okay, we say does not exist. Or maybe you've seen the phrase or the term undefined before. Defined means we know what it is. Okay, when I define a word or a number, I know, I'm telling you the description of it. Okay, how you can identify it. Well, if it's undefined, then there is no such thing to describe that object because it doesn't exist. That is different than being 0. Slope of 0, 0 is a number. It exists. It's defined. Okay, I know what 0 means. Does not exist is undefined. Okay. Previously in some classes, you probably said no slope. I don't like that. I don't like saying that because when people say no, they attach that to the number 0 and they get confused. So I'm going to say a slope of 0 or a slope that is undefined. Okay? So then it's very similar to the equation of this. if I do, let's make a line parallel. So every vertical line is going to be parallel to the y-axis. Now if I put, you see how it writes the equation of that line for me? It just says x now instead of y, and it goes through 7 here on the x-axis, so it says x equals 7. So the way I remember how I write those lines, those vertical horizontal lines, is the letter I use is the letter of the axes that the line passes through. So since it passes through the x-axis, I'm going to use the letter x. And then I write just the number that it passes through, so x equals 3. But the reason for that is, again, put an infinite number of points on this line, or any points on this line, doesn't matter. And what is it telling you x is? X is 3 for all of those. We don't care what the y is. So when writing the equations of either vertical or horizontal lines, you identify the x, or which axis the line crosses. That is the letter you use in your equation. Then set it equal to the number that line passes through on that axis. Okay. I know the notes say this next explanation is y, but I kind of talked through that as we did the examples here. Sometimes they'll give you these questions here where you've got to do a little bit of work. The only time that we can identify the slope directly and the y-intercept directly is if I've got y isolated. Okay, so if y equals mx plus b, then m is your slope, b is your y-intercept. If it's not in that form, you can't make that argument. Okay, you might be able to think ahead and think, okay, well, if I added 2 to both sides, there'd be a plus 2 over here, and that would be my y-intercept, and this negative 3 is going to be my slope. But my suggestion to you, if y is not isolated, highlight it mentally, and then start to work to isolate it. And now you know your slope is negative 3, and your y-intercept is 2. Same thing on this one. I'm going to isolate that guy. So add 9x to both sides. So there's my slope. And 1/2 is my b, or my y-intercept. Remember, that would be the point 0, 1/2. This here would have been 0, 2 for the y-intercept. Sometimes you got to distribute. So I'll have negative 2y here. Distribute my 6. Goes to be 30 minus 18x. Now I need to isolate this y, so I need to divide by negative 2. The only thing you got to pay attention to is you're going to divide everything by negative 2. You divide this side by negative 2, and then this entire side by negative 2. So I give you y. 30 divided by negative 2 is negative 15. Negative divided by negative is a positive, and now I get 9x. Now, remember the coefficient for the x is your slope, and then the constant is your y-intercept. If you want to rewrite that as y equals, use the commutative property, a positive 9x, and then move the 15 that is negative to the back, that's fine. And people like seeing it that way, I think. Next one, just get this y by itself, so subtract negative 1 or 1/2 x from both sides. So you get y equals negative 1/2 x plus 0, which is just this. Now that then is, think about the last section, that's direct variation. Negative 1/2 is your k value, which if you can think about that, k from the last section is the same as m from this section. Still your rise or run. But now there's a plus 0 here that we usually don't write. Think about what we said yesterday, or I guess when we talked about direct variation always goes through 0, 0, and 0, 0 right there. Not only is it a y-intercept, it's an x-intercept. So 0 is your y-intercept. This one's a little bit more abstract. All I'm going to do is try to isolate the y. So I add d to both sides. So I get y equals c times x plus d. And the c is my slope. Okay, maybe there's somewhere later in the problem that tells me c is this value, or c is maybe another, how I can find it with a different equation or whatever. But right now it's just arbitrary. I don't know what it is. And positive d would be my y-intercept. and the point of that would be 0, comma d. We'll stop there for now. Tomorrow we'll pick up with the rest of this and how we graph lines in slope-intercept form. Your homework assignment is going to be just a series of questions that ask you to analyze an equation, determine what the slope and y-intercept is, and then a couple they'll ask you, and here's 2 points, determine the slope, determine the y-intercept, what's the equation. Very similar to the examples that we've kind of went through here inside these notes. If you have any questions, please reach out to me, and I can answer those as needed.